Hey, Math-1s. Today we're going to go over our trig number 3, assignment number 1. Yeah, let's see how well you guys did. All right. First one here, we just want to simplify that expression down to a single reciprocal function, cosecant, secant, or cotangent, just down to 1. Okay, so the first thing I'm going to do here is maybe switch these to sines and coses. Sounds like a good plan. So I'm going to take this cotangent here. Oh, man, it's annoying. Okay, take this cotangent. I'm going to switch it because it's on your formula sheet as either 1 over tan or cos over sine. So I'm going to go to the cos over sine root in this one because secant is 1 over cos. So that's going to reduce out. This will end up being 1 over sine, which ends up being 1 over sine cosecant. Maybe I should write cosecant rather than cos. Cosecant x, and there we go. So this one here, I'm going to multiply at that bottom piece. And the reason I'm multiplying at the bottom piece is because it's a difference of squares. So it'll end up being this at the end after you do the whole distributive property. There are 4 terms there, but they do 2 of them. I'm going to put the 2. 2 of them will reduce out, or just not reduce, cancel out. So then at the bottom there, I see 1 minus sine squared. 1 minus sine squared is the same as cos squared x because of the Pythagorean identity. Right? So you should be able to recognize that one pretty quickly. So this turns into cos squared x. One of these is going to reduce out. So I got 1 on the top still. And then I got 1 of the coses on the bottom. And this is the same as secant x. And there we go. Cool. Let's just put a little arrow here, seeing what I did. There you go. Awesome. We're going to verify this one here. So let's verify these. Kind of like verifying these identities, see if they're true. We're going to verify them for both 30 and for 60 degrees. Remember that pi over 3 is the same as 60 degrees. So I don't have to leave it as pi over 3. I can just put 60 degrees in there. So we're going to do, first of all, let's do it for the 30 degrees. So I'm going to have secant, but secant is the same as 1 over cos 30 degrees. So I'm just going to write that out. Plus tan 30 degrees, okay, cos times 30 degrees, sorry. Oh man, what is this? Okay, 30 degrees. And then there's going to be a minus 1 here. And then I want to see if that is the same as sine 30 degrees. Okay, sine 30 degrees is easy. That's a half. That's just from the unit circle. I'm just going to write that right here. So 30 degrees. The point on the circle at 30 degrees is a half, and the y, and x is root 3 over 2. So that means this cos here is root 3 over 2. I'm going to run out of space, I think, by writing this big. I should write this a little bit smaller. Yeah, 1 minus root 3 over 2. That's good. And it's going to look kind of ugly. Cos is going to be 1 over root 3. It's a reciprocal one, so I'm going to just write that out as 2 over root 3. Right, because it is a reciprocal of that. And tan is going to be 1 over root 3. Just looking at that. Okay. So this will be, in the brackets, 3 over root 3 times root 3 over 2 minus 1. Okay, I'm just going to continue on here. I know it's supposed to equal a half eventually, so let's see. Root 3 over root 3, they're gone. So this will be, this will be 3 over 2 minus 1, which will be 1/2. Well, that worked out. Okay, so that's a bit trickier. Let's see what happens when I put a 60 degrees in there, or the pi over 3, however you want to write it. So let's see, we got 1 over cos 60 plus tan 60 times cos 60 minus 1 is equal to sine 60. Cool. Okay, sine 60 is root 3 over 2. Okay, that's just from the unit circle. That's from, well, you can draw that out over here if you want to, say 60 degrees. This point now is going to be 1/2 and root 3 over 2. Okay. Okay. Cos 60 is 1/2. Okay, that makes this a little bit easier for us. And 1 over 1/2 is just 2, plus this is going to be root 3. Is it root 3? What did I... Oh, I'm looking at the wrong one. It's over there. Yeah, you're right. I don't know what I was thinking there. This could be tricky. Okay, so I'm going to times this by 1/2. Oh yeah, okay, I can see how this works out here. So I'm going to times the 1/2 in. 1/2 times that is 1. 1/2 times this is root 3 over 2 minus 1. 1 minus 1 ends up being root 3 over 2. So it ends up being the same. Cool. What are the non-permissible values for this? Or this is within one circle. Okay, that's not too bad. So remember the non-permissible values of whenever anything's on the bottom. So secant is 1 over cos. So cos x cannot be 0. Okay. Tan is sine over cos. So cos x can't be 0. Actually, that's just the only one then. Cos x cannot be 0. I'll just write down here, since secant x is equal to 1 over cosine x, or tan x is equal to sine x over cos x. Okay, so where is cos equal to 0? Cos is equal to 0. And the x value is 0, so that's straight up and straight down. So x cannot be 90 degrees. You can leave it in degrees because that's what the domain says over there. And 270. Yeah, there we go. Pretty good. Okay, let's write each of these as a single trigonometric function. So we're just going to look at these and try to identify what they are, which identity we would use for these. Okay, so I see cos squared minus sine squared. Look at my formula sheet. I see that down by the cos 2a. So this is the same thing as saying cos 2a, or alpha, where alpha is 15. So this is the same as 2 times 15, which is 30 degrees. And then, so we got that as a single trigonometric ratio, and then give the exact value for the expression. So at 30 degrees, this point up here is root 3 over 2, 1/2. So this is root 3 over 2, because that's the x value. Cool. Okay, so sine cos plus cosine. Sine cos plus cosine. That's going to be the sine sum identity, where this is alpha, this is beta, that's alpha, that's beta. Okay, good. So this would be the same as 35 plus 100, which would be sine 130. Ooh, 135. Now 135 is in this quadrant. Reference angle is 45 degrees. So this point up here is root 2 over 2, but negative root 2 over 2 for the x. The y is still positive, so that means this will end up being root 2 over 2. Or if you memorize the other way, 1 over root 2. To me, they're both the same. Cool. So this last one here, 1 minus 2 sine squared. So let's look down here. 1 minus 2 sine squared. Oh, there's one right there. It's still in the cos. So this is alpha. This is still within the cos 2 alpha range. It's a different way of writing it. There's 3 different ways because they're all they're from the proof, and then I substitute in the Pythagorean identity a couple of times to get those other ones. So what's 2 times 75? 150? Probably, which makes sense. Okay, 150. So this will be cos 150. So where's cos 150? So we're going to look at the picture. 150 reference angle is going to be 30 degrees. This up here, because the reference angle is 30, my y value is a half. My x value is root 3 over 2, but negative root 3 over 2. So this is actually a negative root 3 over 2, because that's the x value. So all this stuff is just from the unit circle, right? So I'm trying to avoid using calculator as much as possible there. Determine the exact value of each of these expressions. Okay, so you want to know, first of all, what angle is that? It's over 12. We usually don't deal with it over 12, but over 12 is 15 degrees. So that I can write this out in degrees, makes it a little bit easier for me to do the math. Negative 15 degrees. So what 2 angles that we know of add or subtract to negative 15? So I can go 45 minus 60, I think. Yeah, 45 minus 60. So that'll work. Okay, then what I'm going to do is I'm going to take that and use my identity, alpha minus beta here. So I get sine 45 cos 60 minus cos 45. I have to make sure they put those right orders. So this is alpha beta sine 60. Okay. Then we're just going to put in the numbers that we know. So sine 45 is root 2 over 2. Cos 45 is root 2 over 2. Those ones are pretty easy. This is the x value. This is the y value. So this is a half. And this is root 3 over 2. So that's just using the unit circle. Hopefully you figure those ones out pretty quickly. There's a minus sign between them. Root 2 minus root 6 over 4. That's it. You can't group those together. They're done. So that's the answer for that one. Cos 150. Okay, so what can we turn cos 150 into? So 150 is, I don't know. Oh, 60 and 45 again. So I can use those 2 numbers, 60 and 45. Doesn't seem very exciting, but those are the easier ones because they're in the first quadrant. I don't have to deal with negatives, apart from the negative in the identity, which is cos 60, cos 45, minus, because it says cos minus sine. Okay, so cos 60 is a half, which we already knew. Root 2 over 2 is a 45. Root 3 over 2, and then root 2 over 2. This is a very similar answer to the previous one. So it's root 2 over 4 minus root 6 over 4, which is root 2 minus root 6 over 4. Actually, it's the exact same answer as the previous one. Ooh. That's just ended up being the same. Maybe I could just double check that. Cos 105 sine negative 15. I don't know if you can see that. It's all kind of messed up in the program. But yeah, end up being the exact same thing. Okay, so let's see what we have here. Angle theta is in quadrant 2, and sine is 7 over 15. So it's in quadrant 2. We draw a triangle in this quadrant. The reason I'm drawing a triangle is because this ratio tells me two pieces of the triangle. It tells me that the opposite is 7, and the hypotenuse is 25. So I can use Pythagorean theorem to find out the rest. So 25 squared. So this is the x value I'm trying to find. So x squared plus 7 squared should equal 25 squared. Oh, I end up getting 24. It's one of those Pythagorean triplets. It's those perfect numbers like 3, 4, 5 triangles and stuff. So we know the x value, but the x value technically is a negative 24. I should probably put that in there because it is going backwards. This is in quadrant 2. Okay. Put a little asterisk there. Very important. Okay, so sine 2 alpha, or sine 2 theta. So I'm going to go here. I'm going to get rid of the 2 part and just use the identity here. So I'm going to go 2 sine theta cos theta. There's only one of them to use. And I'm going to replace in the pieces that I know. Sine theta is 7 over 25. And cos theta is negative 24 over 25. And then we just punch it on my calculator. 2 times 7 over 25 times negative 24 over 25. Math, enter, enter. I like to leave. Oh, that's the most ugly fraction known to man. Okay, maybe not known to man, but ends up being a pretty nice number as a decimal. Since it terminates, that is an exact answer. Cool. 10. Double check it. Yeah. Okay. Tan. There's only one tan theta. If I said this is cos 2 theta, I would have 3 choices. They all should end up being the same answer. Tan only has one choice. It ends up being 2 tan theta over 1 minus tan theta squared. Cool. Let's just put in the pieces we know. So we have a 2. Tan is going to be opposite over adjacent, so 7 over negative 24, and 1 minus negative 7. Just punching my calculator. There's no radicals or anything, so I don't have to worry about trying to simplify this down. So 7 times negative 7 over 24. So the top ends up being negative 7 over 12. Let's go step by step. On the bottom, I have 1 minus 7 over 24 squared. Math, enter. I just ignored the negative there because it just ends up turning positive anyway. Okay, and then negative 7 over 12 divided by this fraction. Math, enter, enter. I get negative 336 over 527. Or some kind of ugly repeating decimal. It looks like it's repeating, but it's not very nice. Cool. There we go. The answer to that. Hopefully you did well, and I'll see you in the next video. Bye.